More than 30 million workers are potentially exposed to one or more chemical hazards. There are an estimated 650,000 existing hazardous chemical products, and hundreds of new chemicals are being introduced annually. This poses a serious problem for exposed workers and their employers. If you are an employee or supervisor working with hazardous substances in your daily work, this course will help you gain a basic understanding of HAZCOM best practices and requirements associated with 29 CFR 1910.1200, Hazard Communication Standard, HCS, 1910.1200. More than 30 million workers are at risk of exposure to one or more chemical hazards. An estimated 650,000 existing hazardous chemical products and hundreds of new ones are being introduced annually. This poses a serious challenge for employers as well as a health and safety hazard for exposed employees. Because of the seriousness of these safety and health problems, and given the lack of awareness among many employers and employees, OSHA issued the original Hazard Communication Standard, HCS, in 1994. The basic goal of the standard is to ensure employers and employees know about work hazards and how to protect themselves. This aims to reduce the incidence of illnesses and injuries from chemical sources. Hazard communication is always in OSHA's top 10 cited standards and consistently ranks at or near the top each year. In March 2012, the Occupational Safety and Health Administration, OSHA, revised its hazard communication standard to align it with the United Nations Globally Harmonized System of Classification and Labeling of Chemicals, GHS. This course will discuss OSHA's 2012 Hazard Communication Standard and how employees can protect themselves from the dangers of hazardous chemicals in their work environment. At the end of this course, you should be able to describe and explain the Hazard Communication Standard, HCS, and Globally Harmonized System, GHS. Define hazardous substance, and give examples of physical and health hazards. Describe the various forms of hazardous chemicals. List and give examples of the 4 primary routes of entry. Describe the 4 types of container and their labels. Identify the 6 levels of the hierarchy of controls. Give examples of the 4 types of chemical containers and labeling requirements. Identify the meaning of each of the 9 HCS 2012 pictograms. Identify and explain the requirements of the Hazard Communication Standard, HCS. Discuss the purpose and major sections of the Safety Data Sheet, SDS. Describe the requirements for Hazard Communication Program employee training. If you are exposed to hazardous chemicals at work, OSHA's Hazard Communication Standard, 29 CFR 1910.1200, aims to help you identify the hazards associated with those materials and guide you on safe usage. Your employer must also teach you about the protective measures when working with hazardous chemicals. When you have this important information, you'll be able to take steps to protect yourself from the negative effects caused by accidental exposure. OSHA's Hazard Communication Standard, HCS, requires employers and manufacturers to develop and distribute chemical information, as described below. Chemical manufacturers and importers must classify the hazards of the chemicals they produce or import, and prepare labels and safety data sheets to convey the hazard information to their downstream customers. Employers with classified hazardous chemicals in their workplaces must have labels and safety data sheets for their exposed workers, and train workers to safely handle those chemicals. Employers who do not produce or import chemicals only need to focus on those parts of this rule that deal with establishing a workplace program and communicating information to their workers, as mentioned above. The standard requires your employer to provide information to employees about the hazardous chemicals to which they are exposed through a hazard communication program, labels and other forms of warning, safety data sheets, and information and training. In this short course, we focus on controls, labeling, and safety data sheets. To learn more about the components of a HCP and how to develop an effective program, be sure to take OSHAcady Course 705 Hazard Communication Program, HCP. Sample quiz. Who must have labels, safety data sheets, SDSs, and train employees on how to handle classified hazardous chemicals. Option A, distributors. Option B, manufacturers. Option C, employers. Option C, sellers. Please keep the answer in your mind. It will be useful at the end. The HCS 2012 is now aligned with the United Nations Globally Harmonized System of Classification and Labeling of Chemicals, GHS. The GHS addresses classification of chemicals by types of hazard and proposes harmonized hazard communication elements, including labels and safety data sheets. It ensures that information on physical chemical hazards and toxicity are available in order to improve the protection of health and the environment during chemical handling, transport, and use. The GHS provides many benefits, including offering a common and coherent approach to classifying chemicals and communicating hazard information on labels and safety data sheets, improving the quality and consistency of hazard information in the workplace, helping to reduce trade barriers, improving productivity for American businesses that regularly handle, store, and use classified hazardous chemicals, reducing costs for American businesses that periodically update safety data sheets and labels for classified chemicals. Sample quiz. The United Nations Globally Harmonized System of Classification and Labeling of Chemicals, GHS, provides a common and coherent approach to Option A, classifying chemical and communicating hazard information. Option B, distributing chemical warnings and literature. Option C, manufacturing and classifying chemical globally. Option D, labeling consumer chemicals and distributing global requirements. Hazardous substances and chemicals. OSHA has defined a substance as a chemical element and its compounds in the natural state or obtained by any production process. This definition includes any additive necessary to preserve the stability of the product and any impurities deriving from the process used, but excludes any solvent which may be separated without affecting the stability or altering the composition of the substance. A hazardous chemical means any chemical which is classified as a physical hazard or a health hazard, a simple asphyxiant, combustible dust, pyrophoric gas, or hazard not otherwise classified. Examples of physical and health hazards: physical hazards, explosives, flammables, gases, aerosols, liquids or solids, oxidizers, liquid, solid or gas. Health hazards: acute toxicity, any route of exposure, respiratory or skin sensitization, specific target organ toxicity, single or repeated exposure, asphyxiants, carbon monoxide, nitrogen, helium, argon, pyrophoric gases, silane, arsine, phosphine, xenon. Real-life accidents. 1. Employee killed when pyrotechnic chemicals explode. At 1:51 a.m. on March 26, 2018, an employee was mixing 100 pounds of pyrotechnic chemicals in a mixer. An ignition occurred as the employee was lifting the mixing blade out of the mixing bowl, which caused an explosion. The employee sustained burns over 90% of the body and died. Real-life accidents. 2. Employee killed by carbon monoxide asphyxiation. At 7:54 p.m. on November 9, 2022, an employee and 2 co-workers were using gasoline-powered 2-inch dewatering pump to remove standing water from a 54-inch culvert. When the employee did not come out of the culvert in the expected time frame, he was found unconscious and unresponsive inside the culvert. The employee was killed by asphyxiation due to high carbon monoxide concentrations inside the culvert due to the pump's exhaust fumes. The chemicals that apply to the rule are not limited to those in liquid, gas, or particulate form. According to the HCS, chemicals can exist in various forms: dusts, finely divided particles. Example: wood dust, fumes. Smaller particles usually formed when solid metal is heated and vaporized, and then condensed as tiny particles, fibers, similar to dusts, but are of an elongated shape. Examples: asbestos and fiberglass, mists, liquid droplets that have been sprayed into the atmosphere, vapors, gases formed when liquid evaporates, gases, substances that exist airborne at room temperature. A vapor is the gaseous phase of a substance usually existing as a liquid or solid at room temperature. Solids. Examples include metal, treated wood, plastic, liquids. The most common form in the workplace. Real-life accident 1. 2 employees sustain chlorine burns. Incompatible chemicals. At 2:45 p.m. on October 1, 2021, Employee 1 and Employee 2, who worked in production in an electroplating facility, were draining a hydrochloric acid tank to replace the contents. The hose the employees were using had been previously used to move chlorine and had not been washed out afterward. When the employees began to use the hose to move the hydrochloric acid, the acid and the chlorine reacted, releasing chlorine gas. The employees were exposed, resulting in chemical burns. Employee 1 was hospitalized for treatment due to inhaling the chlorine. Employee 2 received medical treatment, but did not require hospitalization. Real-life accident 2. Employee is killed in dust explosion. At 1:43 p.m. on August 11, 2023, an employee was observing a production line when he went to the welding box and opened the door, and a combustible dust explosion occurred and a resulting fire. The employee died from his injuries. The effects chemicals have on the various organs of the human body depend on several important factors. The form of the chemical. Is it a solid, liquid, or gas? The route of entry. How does the chemical contact the body? Is it ingested, inhaled, absorbed, or injected? The dose. What amount of the chemical enters the body? The toxicity. How poisonous is the chemical? Routes of entry. Another important task when assessing the workplace for chemical hazards is to determine the routes of entry the chemicals may take. Knowing the routes of entry allows for the determination of appropriate engineering, administrative, and PPE controls to eliminate or reduce exposure. The 4 common routes of entry are: ingestion. Do we eat or drink it? Inhalation. Do we breathe it in? This is the most common route of entry. Absorption. Does it pass through the skin, eyes, or other membranes? Injection. Does it enter through a puncture or cut? Real-life accident 1. Employee dies after exposure to toxic chemicals. At 10:30 a.m. on March 22, 2021, employee number 1 was inside an ISO tank pressure washing the weld seam around the tank's heel when he was presumably exposed to hazardous chemicals. A co-worker and manager found employee number 1 incapacitated, but responsive and breathing on his own. Employee number 1 died after being transferred to a hospital. Real-life accident 2. Employee suffers multiple chemical burns. At 3:10 p.m. on February 2, 2022, an employee was performing maintenance on a Raven AccuFlow system applicator. The employee, who was wearing safety glasses and rubber gloves, began the ammonia bleeding procedure. After approximately 20 to 30 minutes, the employee no longer heard a whistling sound and believed that the system was completely bled out. When the employee removed the filter cap, the remaining anhydrous ammonia in the system sprayed onto the employee. The employee was hospitalized for the treatment of chemical burns to face, mouth, neck, and right forearm. Hazardous substances can be used safely in workplaces if adequate control strategies are used to prevent exposure to those chemicals. Traditionally, a prioritized hierarchy of controls, HOC, is used for implementing feasible and effective controls to safeguard workers. We encourage the use of the HOC as described within the ANSI, ASSP Z10, Occupational Health and Safety Management Systems, to control hazards. The 6 strategies are discussed below. The first 3 strategies are given top priority because they focus on directly reducing exposure to the hazard. Elimination. The best solution is to totally eliminate hazardous substances in the workplace. Substitution. If you can't remove toxic substances, you may be able to replace them with substances that are less toxic. Engineering controls. Redesign or modify processes that use toxic chemicals to eliminate or reduce exposure to the hazard. The remaining 3 strategies aim to manage employee actions to minimize exposure to hazards. Warnings. This strategy aims to influence behavior through heightened hazard awareness. Examples are signs, barriers, and alarms that alert employees to lead hazards. Work practice controls. Work practice controls aim to safeguard employees by implementing safe procedures. To achieve this, the employer can develop mandatory procedures and rules to reduce exposure. Personal protective equipment, PPE. Each employee can be protected when their exposure to chemicals cannot be engineered completely out of normal operations or maintenance work. And when safe work practices and other controls cannot provide sufficient additional protection. Remember, the first question you want to ask is, how can I eliminate, reduce, or engineer out the hazard? Hopefully you'll be able to eliminate the hazard or reduce it to the point where safe behaviors, or PPE, won't. Types of containers and labels. Container labeling is a highly effective method to communicate the physical and health hazards of chemicals used in the workplace. The information on a container label will vary depending on what type of container it is and how it is used. We will discuss labeling requirements under the HCS 2012 labeling requirements in this section. We'll take a look at the labeling requirements for each of the 4 types of containers listed below. Shipped to primary containers. Labels that are shipped to manufacturers or distributors. Workplace or secondary containers. Labels that employers create for their own containers. Stationary containers. Labels on large, fixed, non-mobile storage tanks. Containers or bins. Portable containers. No labels are required if the chemical is used immediately. Updating labels. Chemical manufacturers, importers, distributors, or employers who become newly aware of any significant information regarding the hazards of a chemical must revise the labels for the chemical within 6 months of becoming aware of the new information. To learn more about the 4 types of container labels and associated requirements, visit OSHA's website and download OSHA. Publication 3636. Hazard Communication Standard, Labels and Pictograms. Under the new HCS 2012, containers shipped from manufacturers or distributors must be labeled, tagged or marked with the following 6 items. Product identifier. This should include the chemical identity of the substance. Signal word, danger and warning. Danger is for the more severe hazard categories. Hazard statements. This is a phrase assigned to a hazard class and category that describes the nature of the hazards of a hazardous product and the degree of the hazard. Pictograms. These include symbols plus other elements, such as a border, background pattern, or color that convey specific information. Precautionary statements. These are phrases that describe the recommended measures to minimize or prevent adverse effects resulting from exposure to a hazardous product. Supplier identification. This contains the name, address, and telephone number of the manufacturer or supplier of the substance or mixture. Workplace or secondary container labels. Most employers use the primary containers they purchase to store and use chemicals. However, they might also transfer smaller quantities of these chemicals into their own containers, like coffee cans, drums, plastic jugs, or spray bottles. These types of containers are known as workplace or secondary containers. Ensure your secondary containers are correctly labeled to protect your employees and avoid OSHA citations. One of the most frequent citations is improperly labeled secondary containers. OSHA frequently encounters this issue. And what they see often, they cite often. Remember that the employer must ensure that each workplace or secondary container of hazardous chemicals in the workplace is labeled, tagged, or marked with either the information required on shipped container labels or a product identifier, along with words, pictures, symbols, or a combination of these, which provide at least general information about the chemical's hazards and specific details concerning its physical and health hazards. For fixed stationary containers, employers may use signs, placards, process sheets, batch tickets, or operating procedures instead of affixing labels to each container. These alternatives must clearly specify which containers they are applicable to and convey the information required by 1910.1200 F6. The employer must ensure that the written material, e.g., batch sheets, are readily available to each employee in the work area during their work shift. Portable containers are used to transfer hazardous chemicals from labeled containers and are intended only for the immediate use of the employee who performs the transfer. The employer is not required to label portable containers. Portable containers must be under the positive control of the employee using it. If the employee leaves the container unattended and loses control of the chemical, it must be labeled as a workplace. The secondary container. Drugs which are dispensed by a pharmacy to a healthcare provider for direct administration to a patient are exempted from labeling. Labels on solid materials, for solid metal, such as a steel beam or a metal casting, solid wood, or plastic items that are not exempted as articles due to their downstream use, or shipments of whole grain, the required label may be transmitted to the customer at the time of the initial shipment and need not be included with subsequent shipments to the same employer unless the information on the label changes. For example, treated lumber is covered since the lumber is not completely cured at the time of shipment, and the hazardous chemical will, to a varying degree, off-gas during shipment and be available for exposure to employees. Railroad ties treated with creosote should have an accompanying safety data sheet, SDS, when shipped. The HCS 2012 requires that labels have GHS pictograms to alert users of the chemical hazards to which they may be exposed. Each pictogram consists of a symbol on a white background framed within a red border. Each one represents a distinct hazard. The pictogram on the label is determined by the chemical hazard classification. The GHS uses a total of 9 pictograms. OSHA will only enforce the use of 8. The environmental pictogram is not mandatory, but may be used to provide supplementary information. The HCS 2012 requires chemical manufacturers, distributors, or importers to provide safety data sheets, SDSs, formerly MSDSs, or material safety data sheets, for each hazardous chemical to downstream users to communicate information on these hazards. SDSs are required to be presented in a consistent user-friendly 16-section format. We will discuss this format in this module. The SDS includes information such as the properties of each chemical, the physical, health, and environmental health hazards, protective measures, safety precautions for handling, storing, and transporting the chemical. The information contained in the SDS must be in English, although it may be in other languages as well. OSHA requires that SDS preparers provide specific minimum information, as detailed in Appendix D of 29 CFR 1910.1200. The SDS preparers may also include additional information in various sections. Employers must ensure that SDSs are readily accessible to employees. The HCS 2012 requires new SDSs to be in a uniform format. They must include section numbers, headings, and associated information under the headings below. Section 1. Identification. This section identifies the chemical on the SDS, as well as the recommended uses. It also provides the essential contact information of the supplier. The required information includes product identifier used on the label and any other common names or synonyms by which the substance is known, name, address, phone number of the manufacturer, importer, or other responsible party, an emergency phone number, recommended use of the chemical, e.g., a brief description of what it actually does, such as flame retardant, and any restrictions on use, including recommendations given by the supplier. Section 2. Hazards identification. This section identifies the hazards of the chemical presented on the SDS and the appropriate warning information associated with those hazards. The required information for this section includes hazard classification of the chemical, e.g., flammable liquid, Category 1, signal word, pictograms, hazard statements, precautionary statements, description of any hazards not otherwise classified. Section 3. Composition information on ingredients. This section identifies the ingredients contained in the product indicated on the SDS, including impurities and stabilizing additives. This section includes information on substances, mixtures, and all chemicals where a trade secret is claimed. The required information in this section includes Substances, chemical name, common name and synonyms, chemical abstracts service, CAS, number and other unique identifiers, impurities, and stabilizing additives which are classified and which contribute to the classification of the chemical mixtures. Same information required for substances, chemical name and concentration, that is, exact percentage, of all ingredients which are classified as health hazards and are present above their cutoff concentration limits, or a health risk below the cutoff the concentration limits, and the concentration, exact percentages, of each ingredient, chemicals where a trade secret is claimed. A statement that the specific chemical identity and or exact percentage, concentration, of composition has been withheld as a trade secret is required. Section 4. First aid measures. This section describes the initial care that should be given by untrained responders to an individual who has been exposed to the chemical. Required information includes necessary first aid instructions by relevant routes of exposure, inhalation, skin and eye contact, and ingestion, description of the most important symptoms or effects, and any symptoms that are acute or delayed, recommendations for immediate medical care, and special treatment needed when necessary. Section 5. Firefighting measures. This section provides recommendations for fighting a fire caused by the chemical. These recommendations include suitable extinguishing equipment and information about extinguishing equipment that is not appropriate for a particular situation, advice on specific hazards that develop from the chemical during the fire, such as any hazardous combustion products created when the chemical burns, recommendations on special protective equipment or precautions for firefighters. Section 6. Accidental release measures. This section provides recommendations on the appropriate response to spills, leaks, or releases. It includes containment and cleanup practices to prevent or minimize exposure to people, properties, or the environment. These recommendations include use of personal precautions and protective equipment to prevent the contamination of skin, eyes, and clothing, emergency procedures, including instructions for evacuations, consulting experts when needed, and appropriate protective clothing, methods and materials used for containment, cleanup procedures. Section 7. Handling and storage. This section provides guidance on the safe handling practices and conditions for safe storage of chemicals. This guidance includes precautions for safe handling, including recommendations for handling incompatible chemicals, minimizing the release of the chemical into the environment, and providing advice on general hygiene practices, recommendations on the conditions for safe storage, including any incompatibilities. Provide advice on specific storage requirements, example, ventilation requirements. Section 8. Exposure controls, personal protection. This section indicates the exposure limits, engineering controls, and personal protective measures that can be used to minimize work exposure. These include OSHA permissible exposure limits, PEL, American Conference of Governmental Industrial Hygienists, ACGIH, threshold limit values, TLVs, and any other exposure limits. Appropriate engineering controls, recommendations for personal protective measures to prevent illness or injury from exposure to chemicals, such as personal protective equipment, PPE, any special requirements for PPE, protective clothing or respirators. Section 9. Physical and chemical properties. This section identifies physical and chemical properties associated with the substance or mixture. These properties include appearance, physical state, color, etc., upper or lower flammability or explosive units, odor, vapor pressure, odor threshold, vapor density, pH, relative density, melting or freezing point, solubility, initial boiling point, boiling range, flash point, evaporation rate, flammability, partition coefficient, Nachtenoir water, autoignition temperature, viscosity. Section 10. Stability and reactivity. This section describes the reactivity hazards of the chemical and the chemical stability information. This section is broken into 3 parts. Reactivity, description of the specific test data for the chemicals. Chemical stability, indication of whether the chemical is stable or unstable under normal temperature and conditions. Description of any stabilizers. Indication of any safety issues, should the product change in physical appearance. Other. Indication of the possibility of hazardous reactions, and conditions under which hazardous reactions may occur. List of all conditions that should be avoided. List of all classes of incompatible materials. List of any known or anticipated hazardous decomposition products. Section 11. Toxicological information. This section identifies toxicological and health effects information, or indicates that such data are not available. This section identifies information on the likely routes of exposure. The SDS should indicate if the information is unknown, description of the delayed, immediate, or chronic effects from short and long-term exposure, the numerical measures of toxicity, the estimated amount of a substance expected to kill 50% of test animals in a single dose, LD50. Description of the symptoms. This description includes the symptoms associated with exposure to the chemical, including symptoms from the lowest to the most severe exposure. Indication of whether the chemical is a potential carcinogen. Section 12. Ecological information. Section 13. Disposal considerations. Section 14. Transport information. Section 15. Regulatory information. Note: OSHA does not enforce sections 12 through 15, because other agencies regulate this information. Section 16. Other information. This section indicates when the SDS was prepared, or when the last known revision was made. It may also highlight what changes have been made compared to the previous version. You may wish to contact the supplier for an explanation of the changes. Additional helpful information might also be found in this section. SDS management. Below are some more important requirements manufacturers, importers and distributors must meet. Prepare one SDS that applies to all similar mixtures where complex mixtures have similar hazards and contents, that is, the chemical ingredients are essentially the same, but the specific composition varies from mixture to mixture. Ensure that the SDS information recorded accurately reflects the scientific evidence used in making the hazard classification. Update the SDS within 3 months after becoming aware of any significant new information regarding the hazards of a chemical, or ways to protect against the hazards, if the chemical is not currently being produced or imported. Add any new information to the SDS before the chemical is introduced into the workplace again. Provide an appropriate SDS with the initial shipment, with the first shipment after SDS is updated, and as requested by the employer or distributor. Retail distributors selling hazardous chemicals to employers having a commercial account must provide a SDS to employers upon request and post a sign or otherwise inform them that a SDS is available. Employer responsibilities. Employers have many important required responsibilities under OSHA's Hazard Communications Standard. If an SDS is not provided with a shipment labeled as a hazardous chemical, employers must get the SDS from the chemical manufacturer or importer as soon as possible. Employers must maintain SDSs in their workplace and ensure that they are readily accessible during each shift to employees in their work areas, electronic access, and other alternatives to maintaining. Paper copies of the SDS are permitted as long as no barriers to immediate employee access are created by such options. Ensure employees know how to quickly access SDS information that is stored on computers or online. Where employees must travel between workplaces during a shift, i.e., their work is carried out at more than one geographical location, the SDSs may be kept at the primary workplace facility. In this situation, the employer must ensure that employees can immediately obtain the required information. In an emergency, employees who work at more than one site during the work shift must be able to obtain SDS information immediately, within seconds. In an emergency, SDSs may be kept at the primary workplace facility, as long as the employer has a representative available at all times to ensure ready access, within a few minutes, to this information. This is the only situation in which an employer is allowed to transmit hazard information via voice communication. The employer must address in the written hazard communication plan how SDS information will be conveyed to remote work sites. SDSs may be kept in any form, including operating procedures, and may be designed to cover groups of hazardous chemicals in a work area where it may be more appropriate to address the hazards of a process rather than individual hazardous chemicals. Training requirements. Employees must receive information and training that ensures their awareness of the chemical hazards used in their work area. Employers must provide this information when an employee is initially assigned to a work area where hazardous chemicals are present and before assignments involving new exposure situations. Employees must be informed of the requirements of the HCS 2012, any operations in their work area where hazardous chemicals are present, the location and availability of the written hazard communication program, including the required lists of hazardous chemicals and SDSs required by the HCS. To make sure all training requirements are met, we recommend reviewing each section of the SDS. Group discussion and examples can be effective training strategies to make the training more interesting to students. To help ensure the effectiveness of the training, demonstrating and practicing the use of PPE for proper usage and spill cleanup is especially important. Training topics, information, and training may be designed to cover categories of hazards, for example, flammability, carcinogenicity, or specific chemicals. Chemical-specific information must always be available through labels and SDSs. Employee training must include at least the following topics: methods and observations that may be used to detect the presence or release of a hazardous chemical in the work area, the physical hazard, health hazards, simple asphyxiation, combustible dust, and pyrophoric gas hazards, as well as hazards not otherwise classified of the chemicals in the work area. Employees should be aware of the measures they can take to protect themselves from these hazards. This includes specific procedures the employer has implemented to protect employees, such as appropriate work practices, emergency procedures, and personal protective equipment to be used. Employees should be informed about the employer's hazard communication program. This includes explanations of the labels received on shipped containers and the labeling system used in the workplace. They should also be educated on the safety data sheets, their layout, and how to access and use the appropriate hazard information. Training at multi-employer worksites. If the employer becomes aware of new exposure risks for their employees at a multi-employer worksite, the training requirements still apply. Employees must be trained for hazards they haven't previously been educated on. Training temporary employees. Training temporary employees is a responsibility that is shared between the host employer and temporary agency. Host employer. The host employer is responsible for training on the company's specific HCS program requirements, including labeling, chemical hazards, and safe work procedures in their workplace. Temporary agency. The temporary agency, in turn, maintains a continuing relationship with its employees and would be expected to inform employees of the general requirements of the HCS standard. Contracts between the temporary agency and the host employer should be examined to determine if they clearly outline the training responsibilities of both parties, in order to ensure the employers have complied with all requirements of the regulation. Training for emergencies. A frequently overlooked portion of the training provisions is dealing with emergency procedures. The scope of employee training depends on the extent to which the employer plans to respond to emergencies. The HCS training program may need to include the Emergency Action Plan and/or the Hazardous Waste and Emergency Operations Emergency Response Plan as follows. Emergency Action Plan EAP. If the employer merely intends to evacuate the work area, the training in emergency procedures could be limited to information on the emergency alarm system in use at the worksite, evacuation routes, and reporting areas as detailed in the employer's Emergency Action Plan under 1910. 38. Emergency Action Plans. Emergency Response Plan ERP, where employees are expected to moderate or control the impact of the emergency in a manner similar to an emergency responder. Training under 1910.120. Hazardous waste and emergency operations would be required. Real-life accident rescuer killed when overcome by hydrogen sulfide poison. At 6:45 a.m. on March 10, 2020, employee number 1 was attempting to rescue employee number 2 from hydrogen sulfide poison. He was overcome by the hydrogen sulfide and was killed. Employees were exposed to contaminants without the employer estimating exposure or considering the atmosphere to be immediately dangerous to life and health by DLH.